Okay, guys, welcome to QA/QC 101 Rush version. Okay, this is it's in Spanish, it doesn't matter, I will explain it, but this is a course of 4 days of 4 hours each that I'm gonna give you in 1 day in 4 hours. And on top of that, we're gonna do a lot of practice, and on top of that, we're gonna make a lot of decisions. Okay, so, and I'm gonna make some breaks so you can rest a little bit while you're working. If you get any problem with the video, with the TV, tell me, because I don't see it. Actually, I need to film the TV. So you're already on camera. But I need to film it there. Yes, so it will be a video with my voice and what is on the screen. So we will start with QA, which is quality assurance. Then we will go to QC, which is quality control. Then we will go to the most important part, which is how to name rocks and alterations in the field. And then we will finish with a summary. I'm going to talk also about the drilling process. Okay, so let's go down here. So you know me, I just wanted to tell you that there is this book, okay, it's called Quality Assurance. Turn off your cell phone.
Switch off your phone.
Which is called Quality Assurance and Quality Control, and I strongly suggest that you buy it from Amazon. There is a link down here. This is the Bible. This is the step-by-step instruction on how to do all that we're going to be talking today. Okay, and there is a lot of things that we're going to be doing. Also, I have here another book which is called Systematic of the Magmatic Processes, which is a book like this thick, okay? But it shows absolutely everything that you need to do with magmatic rocks, from how to study, how to sample, how to interpret results, absolutely everything. And the last one is the exploring geological data. This is a manual for understanding and applying artificial intelligence to geology. So as I mentioned, this is the book, this is where you can find it. And let's start with why it's so important to have the QA and QC. And everything started in 1996, okay, which I call the beginning of the end. There was a company that made a discovery in Indonesia. The company was called BRIX. And they apparently discovered the biggest gold deposit in the world. And the price of this company, the price of the geology company, went from 10 cents to up to $286 in less than 6 months. I was working in Ghana at that time, and I will never forget this. My boss at that time was looking at the paper called the Northern Miner, and he saw about this BRIX, and out of the blue, he said, I'm gonna buy. And he bought like $300 of shares of this company, and he sold them when they were at $200. He made so much money that he didn't need to work anymore. And what happened is, whenever there is something that seems to be too good to be true, usually it isn't. The geologist soiled the samples. So what he did, he went to the field, he panned gold from the river, and then he grabbed this little nuggets and put it in the bags of the drill log that were sent to Canada for analysis. And of course, all the sample came with not only gold, with huge amount of gold. There is a movie called Gold. If you can find it in Netflix or something, I recommend it. It's pretty close to the reality, although they put there the geologist as a Colombian guy, which is not, he was an Indonesian guy. But the fact of the matter, the truth is that the owner of the company was not a geologist, okay? He was an investor and he worked in mining many years. And one day he had a dream, and I'm not joking. He had a dream that in some place in Indonesia there was the biggest gold deposit in the world. And based on a dream, he wake up the next morning, sold everything he had, including his watch, and he flew to Indonesia. He found a geologist down there, and he went into the jungle, and suddenly he looked, well, that picture there, that sun there, he looked at the mountain and said, here it is, this is what I dreamed. And without absolutely anything else, they started. Of course, there's nothing there, but he put all this money on, and this guy, the Indonesian guy, it's not clear why, but he helped him by soiling samples. So it's all starting to come, and the gold price were, I mean, the shares of this company were to the roof. And
1 second, your video is not well.
Oh, well, you can put it right here in the middle, so it would be. No, you cannot move it like that. You can put it here. The stand. You put the stand here.
Looks better now. Yeah, it's better.
Okay.
Peter.
So, of course, when your company's shares price are going to the roof, all the big companies like Ari, all these guys started to be interested, and they wanted to buy the company. And of course, they wanted to do what is called the due diligence. So they would send a geologist or 2 or 3 geologists to the field to check the data. And that is when the bubble burst. Because when the guys went there and took sample, independent sample, came back, no gold. And that was the first, you see this bump here? The first time the price went down a little bit. But you know the saying that there is no worse stupid guy than the one that doesn't want to learn. People wanted to believe that this was true. So the price kept going until a group of Canadian journalists from the time made an article where they proved beyond any doubt that this was not true, that they even took photographs of the nuggets of gold, rounded nuggets of gold inside the rock. So at that moment, the price went from 200 and something down to 0. And that was in 1997. You could not find a work in geology anywhere in the world because it was such a horrible news that people lost faith in mining. So, as an anecdote, there is a bar in Toronto, that Front Street next to the lake, that the owner of the bar used to have a lot of shares from Briex, and when they lost the value, he didn't get, well, he got angry, but as a joke, he took his shares and he posted on the wall like wallpaper. And everybody from Toronto that had the share, they came and put the shares on the paper. So there was, all the walls were covered with shares of certificate of Briex, which costs here. Now, this was really, really bad for the industry. As I said, nobody would put a cent in geology because, okay, why see? And it also coincides with the rise of the dot-com phenomenon. When you know, these companies are out of the blue, they come, they make software, and they make millions. Okay, so what was the solution? And I'm very proud to say that the solution came precisely from the Canadian geologists. And the Canadian geologists created the National Instrument 43101. And this is why it is so important that you all geologists know about this thing. They introduced 3 concepts: the concept of a qualified person, the concept of the standards and best exploration practices, and the actual report. And just to put a little bit ahead of time, a technical report is a geological report made by an independent person that states the quality of the project that you're visiting. And it must be fair, and you cannot use adjective. For example, I cannot say, oh, this is a world-class deposit. No. You can say, this deposit has so many million tons. And that way, the investor, especially the knowledgeable investor in Canada, we have a lot of people that know very well about investing in mining, they will take this report that has a format, and they will quickly look at the places and say, okay, this is good. And why it is good? Because if the author of a 43-101 lies, he goes to jail by law. He needs to pay horrendous fee. I mean, you are responsible legally and criminally for what you write in the report. So those three things save the geology of the world. And immediately after us, the Australians created their own, which is called the York. The Africans, the South Africans created their own, which is called, I think, Samarak. Will we please?
The IT guy.
Because it just disconnected me when I say. Okay. Okay, I forgot what I was saying.
The Africans,
the Africa created the Samarak.
Africans.
The South Africa created the Samarak. The American created the CAG, etc. So every country, not every country, but 4 or 5 countries created similar thing. And in March of 2019, everybody joined together to unify all the concepts. And right now, they are very, very similar. The only difference, for example, between a York and a National Inter 43-101 is where you're located in the world. America and Europe, they prefer 43-101. Asia and Indonesia, they prefer the York. But they are interchangeable. Now, this site here, I want you to write it down. It's called, the best practice is cim.org. Okay, you go to cim.org. And there you will find 2 good things. There is one page, it's called standards, which mean what are the definitions of everything. The definition of everything, but the most important for you is this one here, the best practices. They explain how to do the basic of every single type of sampling. And this is the basis that we need to work with. Okay? Now, we were talking about the qualified person. The qualified person is a very important key in this system. Then I will explain you what are the characteristics. But when do we bring the qualified person? We should bring the qualified person like Kunle did here at the beginning of the project. Why? Because if I come right here and all the work is done, then my function is just to evaluate the work done. So if there was a mistake, there is no way to fix it. I just say, well, this was a mistake. And let me tell you, as a reference, last year I did, already 2 years ago, I did a job in Colombia for a gold mine that has been in exploitation for 72 years. Okay, it's a gold mine, is there is no doubt about it. They had close to 250,000 data points within the mine. And I could not use one single point because in 72 years, they never did a quality control. Therefore, it's not that their data is bad, it's that we cannot verify that the data is good. So therefore, it's like, I just came there and there was nothing. I mean, usually when you tell that to the company, they just fire you on the spot, they don't pay you, blah, blah, blah. But these guys were really good, a group of friends from the States. And they say, well, what do we need to do? I said, well, we're going to do a control, a twinning of some sample, blah, 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 blah. We will do the assay, the retesting, and I will find out if they are correlated. And thank God, yes, they were correlatable, So I could use the whole data and then give them the resource estimation. But that is why it's good to have the qualified person right here, even at the moment of planifying the work, okay, and during the work to train, etc. So what Kunle did here is very good. So what is the qualified person? The qualified person need to have what is called the 3 E's: education, ethics, and experience. First of all, the ethics. You need to belong to a professional association with criminal and legal power to put you in jail or to fine you if you do work that is not good. And that is very important. That is why many countries, no matter how good the geologists are, they cannot have qualified person because there is not such entity. The entity that I belong to, the Professional Society of Ontario, if I lie, not if I make a mistake, because mistake, everybody can make it, but if I lie on purpose, somebody paid me to say that there is so many ounces, I go to jail, and not only me, my property, everything is in the line. Second, you must have education. And education means a university degree, and more important, the most important thing, you need to have courses on statistics. And that is a problem in Colombia. For example, they have very good geology, they have everything, but they don't teach statistics at the University for Geologists. So they are excluded automatically. And the third one is experience. Because a qualified person, for example, I have 37 years of international experience, but I cannot work in coal because I have never worked in coal. Okay, so you need to have experience in the metal that you're working with. And not only experience, relevant experience. So what I'm showing you here is the format. Just a second, I asked for a bottle of water.
Yeah.
What I'm showing here is the format of the 43101, and every single report of 43101, I cannot, thank you. Every report 43101 has the same structure, and that is why the investor can quickly go and search the information that they need. I used to say that the 43101 is a picture that the qualified person takes when he makes the visit to the company the first time. So how things are at the moment of the visit. What you see there in bold, summary, introduction, etc., these are the most important parts of the report. And as I said, it's like a picture, and you know the picture is just smile, that's it. But there is one point that is not just a description of what happened. It's an evaluation of the quality of the work, and that is the data verification. And that point alone, point number 12, could kill a project like that. The data verification is the only part of the report where the qualified person needs to give a concept. This has been done in accordance with the best practice, or no, this has not been done. And if I put in the report, like was the case, as I mentioned, that they haven't done any qualified quality control sample for 72 years, therefore my conclusion was there is data, but it cannot be verified. Therefore, the resources cannot be approved. That's it, end of the query. So as I say, data verification is the most important part. And data verification is not only come and see, okay, what is the QCs that you have? Oh, you use some duplicates, standards, okay. No, not only that. You do, for example, you go to the field and you go to the drill patch, okay, to the drill site, and you check the coordinates. You check even the inclination, and you will not be surprised. Sometimes the holes were done in the wrong orientation, instead of being that way, was done this way. So you need to do a lot of detective work. It not only asks, is just have your eyes open. And again, all this is just flying through this. So as I said, type of verifications. And that is why it is mandatory that the qualified person visit the property. I mean, without that, there is no way the report will be accepted, except, of course, now with the COVID, that it was so difficult to travel. The TSX, the Toronto Stock Exchange, or other exchanges, they will allow you to write the report and present it and file it with the understanding that as soon as it's possible, the qualified person will visit the property and then reissue the report. For example, there was a war or hurricane or whatever, there was some reason that you were not able to visit the site. You can do the report, file it, but nobody's gonna pay attention to the report until the qualified person visits. Because at the end of this 43-101 report, there is a letter from the qualified person saying, I visited this day, I did this, and I certify that all is, like the Jewish say, share. It's good. We don't have breaks here, we go straight forward. So, we're going to talk now about how to design a QA/QC program, what are the most common type of control samples, what is a QA/QC for the field, how can we determine the quality of the QA/QC, the diagram of the QC, and we will talk also about how to name rocks in the field. Now, this part, the QA, is the part that is less explained and is the most important part, because the QC is easy. You have certain type of control, you put it at a certain interval, you get certain result, you process, but it's clear. But the QA is much more complex than that. The QA is how we do the work. Okay? And when you will have visits from a mining analyst, from a firm that will write about your company, if you can present to them a document, say, these are our QAs, you already have 70 points in your bag, because almost nobody does. Okay? So this is one thing that you will do. Okay? You will have a set of QA. It could be written, it could be a video, it doesn't matter, but there should be. And for you to understand me, for example, the first QA that you're gonna write is how you did the sampling with the hour. And this has not to be a very complex document, it's just a description. We get to the point, we clean the place, we make a hole, we take the sample, we just step by step, and just explain it. So when an audit, you have an audit, another person come and say, how do you take the sample here? Or you get a new geologist, you don't need to train, you say, read here. Okay? So this is very important. This is one of the simplest one. I'm going to show you there are many, and we need to have this thing done. For example, right here at the left, there is a flow chart of how we take the sample in the field and send it to the lab. What kind of assay do we need to do? What is the weight? All the part of the process. And when we send samples to the lab, before using the lab, we do an audit of the lab. I'm going to sit down with the laboratory and discuss every single point of the process of the sampling. I usually get to a new lab and say, hi, my name is Ricardo. Think that I am a sample. Take me through the process. And they take me to the different places, blah, blah, blah. So that's called an audit. And geologists are afraid of doing this and say, no, the lab loves this. Nobody visits the lab. So when a geologist visits the lab, they feel good. Okay, so good. So you need to have this kind of flow chart prepared to discuss with the lab, and you need to have a contract with the lab that explains absolutely everything. Like, For example, what happens if a duplicate fails? Or repeat the sample, who's paying for that? The lab, okay. No, you, oh, no, we discussed. Okay, so that needs to be clear, and that is part of the QA. Here to the right, and we haven't done this at the moment, but I hope that for the next batch of work, we're gonna do this. At this moment, you are just taking the sample. You're not doing much of a description of the sample in the field. My concept of field work is like Attila. You know Attila? On the elephants that we say where Attila passed, not grass left began. So I create a team of not only the chemists, the geophysics, the geology, they work all together and they go into the field like in a team. And once they pass a point, they don't need to come back. Normally in many companies, they send first the chemists, then the geophysics, the geology go by their own side, etc. etc. No, have it all in one group and do all the job. It's slower, but it's faster because you finish all the job and you have the advantage of talking to each other. Okay, so this one here is what I call the codified cards. This one is for a technical or even a person that is not a geologist, because as you can see, the information is very simple. You don't need to be you just need to know how to read and write. So what is the color? What is the value of the capometer? What is the value of the radiometer? What is the temperature of the soil on the surface and on the ground? And let me tell you why this is. And you will be amazed. You need to have a thermometer, like a laser thermometer, like for cooking. Why? Because if you go in the field and you measure the temperature on the surface, you make a hole to take the sample, and you measure the temperature at the bottom of the hole, there will be a difference of several degrees. And on top of mineralized zone, that difference will be bigger than on buried soil. Why? Because all the metals, they have bacteria living, eating that metal. And when they fart, what they fart is methane, CH4. And methane is a gas that is cooler than the oxygen. So you get a cooler temperature close to the ore body than not. I discovered this is a technique I discovered in working in Burkina Faso. In winter it was 42 degrees. And anyway, the difference was of several, like 10, 12 degrees difference between the mineralized zone and all. So just with the thermometer in the field, you will have a very good idea of this thing. And the pH, the acidity, and as you can see, there is 4 boxes for the composition of the soil. Sand, you fill the sand. Clay, again, it is plastic. Clayish, sandy clay, clay sandy, and carbonate. For carbonate, you need to have a little bit of chloric acid or even a lemon. You just take samples, squeeze it. You see some fizzing, okay, there is carbonate. So they just make a mark. And then you have the number of the sample. Just take one, put it in the sample, that's it. So you can see even a non-geological can give you a lot of information. But then for geologists, we have more complicated codified cards. And I have these cards for all types of work. Soil sampling, rock sampling, water sampling, biological sampling, for everything. And the advantage is, first of all, you put a lot of information in this card. But one of the best things is that you have aside a description of, for example, what 1A means. This AB, AB, or ABC, ABC. You have a part, what is that information? For example, 1A is a flat terrain. And you work in a flat terrain, you just make a cross in 1A. But if you don't have this key, there is no way that you know what does that mean. So these cards are really, really secure. And the other big advantage is that you don't need to translate. I mean, anybody can read this card because you have this instruction in English, in Russian, in Arabic, in whatever. So these things, it takes a little more time to introduce, but this is what we want to go. This is what we want to get. But at least for the next campaign, use this little cards here. Now, another part of the QA, which is the systematic of how we are going to name the rock. And here you have the flow chart that we're going to be using. This is specific to how to determine the igneous rocks. Let me see if I can make this bigger. Yes. For example, it's a very simple flow chart. You get the sample, and you ask yourself, the sample dark. Always yes it to the right, always no it to the down. Okay, let's say it's dark. Is it heavy? Okay, it's heavy. Does it have volcanic structure? Let's say no. Does it have more plagioklass than pyroxene? Yes, it's an anorthosite. Okay. So it's very, very, very simple. You get to all the names of the basic rocks just by following very simple yes, no questions. I say a kid could do this. Oops, what I did, I don't care. Let's go. Okay. And I did this in 1997. I was working at the University of McGill. My students had a lot of problems naming this rock, and I just did this for them. I mean, this is very simple. So, also in the realm of QAs, you have the core shack, okay, and all the methodology of how to prepare the core shack, etc. This is how we want to do it here, okay. This is an example of where we put the core, okay, here to the right, and we use plastic core boxes, as you can see here. To the right is the section where the guys were preparing the sample, cutting it, etc. Look at all the protection equipment they used. It was really good. Now, here's an example of the use of the rolling desk that I was showing. We want to have it so the people, the geology, can do direct logging in the field, because normally, it's okay. You write it on a paper, you know, a form, whatever, and then you sit down and you write on the computer. Well, double the work, and many times you don't understand exactly what was written, or rain start, whatever. A lion came into the camp. Okay, so it's better not to have it. So this is the tables. This is the little one. What else do I have here? And this is these posters. These are the posters. These are the posters that I want you to do. These are going to be on the wall. These are going to be on the wall of the core shack. So while you're doing the logging, you can just look up and say, okay, oh, that's it. Okay. You can also have this. You can also have this.
Keys there. Yes. Remove it and jam the door. Thank you.
It just disconnects me what I'm saying.
Oh, especially this guy, yeah?
Yeah, that's a good sign. Okay. So you put it on the wall, and while you're working, you can see. But you can also have this thing on small size, so when you are in the field, you can check it. Okay. By the way, this guy here, these two guys, they are the top gold specialists from Brazil. And when I was working, this is in Colombia, and I was working. We wanted to sell the mine. They sent the company that was buying was Brazilian always. they sent their two top specialists to visit us. And they were just so amazed with our core shack and all this QAQC that they wrote a letter, and I'm very proud of this. They wrote a letter where they said like 13 points, and of the 13, 10 were, you need to do this like Calvista, you need to do it like they do it. So this is the picture, the picture station, okay? So every core needs to be photographed. Once it's cut, you put it here, and then you do the photograph. And you have a scale from 0 to 1 meter. You have here information to put from to, what box is, the date, and the number. And here you have a color scale. Because one thing, even when you're using good camera, when you take the picture, the colors in the picture are not recognizable, okay? But if you have in this picture, you have a color scale, then you can say, okay, this is blue, okay, perfect. Okay, so this is very important to have a gray scale and a color scale. We already have this, and this is how the table looks. So what you do, this is like a 45 degrees. You put a tripod with the camera fixed. I mean, you mark in the ground where the position of the legs of the tripod is. And you got the camera at a 45 degrees angle, which means that it will be a 90 degrees on the surface for the photograph. This is very, very important. It must have good illumination. Okay? And every core box will be a photograph. Now, one more thing about the drill, the core. Once you get the result from the lab, you need to go back, for example, and mark on every box where were the good gold values. Like put like a red marker on the box, and then look at the rock, study them. Why this rock got a very good gold value and this one didn't. And then next time, you're gonna have your eye already trained. Another thing that we always do, and all this is part of the QA, and this video will serve you as your QA, okay? We will weight every box that comes from the drillers, because if the rock is mineralized, it will be heavier. So just by weighting the box, the guys will know, okay, this is heavier. We used to put a red tag on the core, so when the geologist will come and do the logging, they will see that, oh, this core is heavy. Let me check. Okay, that is why I want to weight the samples from the field, and it's not possible that all the samples were the same weight. We need to check that.
You mean, sorry, you want to wait on the site or here in the core?
No. The core, I'm talking about the core is here in the site. Okay, I'm talking about the soil sample.
Oh, the soil sample. Oh, okay.
So this is where we had this is the core, the preparation site. As you can see, huge. Actually, our preparation site is the size of the whole core shack, but I mean, we did have a very good place there. This is the machine with the extraction unit, and this little fellow here, that is the crusher. Okay, so what happened? You know that one of the QC that we take is a duplicate. Okay, and what is usually is done everywhere is that you take half of the core, okay, and that half you split it in half. One will be the sample, and the other one will be the duplicate. But gold has the nugget effect. It may be that the only piece of gold that was in the rock fall on this side and not on this side, and the result will be bad. The best way of dealing with this is to take the whole meter, crush it, the whole meter, split it in two, and then leave one split on the box and take the other split. And that split again into two, one will be the duplicate, one will be the standard. That is the best way of preparing a duplicate. That is why I want you to have the crusher and the splitter. And that is a splitter. You see? So this is a crusher, that is a splitter. You split all the samples, half goes into the box, then you split it again. One would be the duplicate and the other one would be the original sample. And this here is another shack. This is not to put the core, it's to put the rejects. When the lab finished processing this thing, all these rejects you need to take them back and organize them. Why? Because at some point you're going to need to do metallurgical testing. And instead of going to the field, looking at excavator, making a hole, no, you have already the material here and you already know what is the grade on this thing. So you can say, okay, I need 50 kilograms of a material that is running 0.5 grams per joule. You go to your data set, okay, box number, blah, 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 blah. You go select the box, that's it. Your metallurgical testing is prepared. This is very, very important. Now, I'm gonna show you this little video. This, remember when I was telling, it's in Spanish, it doesn't matter, I will comment. But what I was telling you, the way we work, I call it the Valls Consultant Complex System Approach, to do everything together. Okay, it's like 5 minutes. Take a look at it. And I will comment. Because the audio is not good, it was filmed in the outside. Oh, of course, I don't have access to the internet. Sorry, we'll not do it. I will do it another time. And I mentioned the use of a condom to get the best exploration sample. I mean, this is by far.
Put up your phone.
You're close to him. Hit him on the desk. Thank you. Okay, so this is the method is very simple, but the methodology of taking the sample I'm going to explain, because for further work, when you're working, especially in, you need some?
You brought some condom.
Okay, so how do we do this work? You have been done so far soil sampling, which is very good method. But we do soil sampling when the area is not too big or when we already have an idea of where the mineralization is. But when you're working on big regional areas, you cannot do soil sampling. You're gonna spend all your money. So what you do is usually do string sediment and panning. For that, you start by doing what is called a geomorphological study of the area. You just take a topo map with a pencil and you join all the higher peaks in the area, and you will get like basins. Okay, these basins are called basins of denudations. So you have an anomaly here. You know that it comes from within this basin. It cannot come from the other one because this is a watershed. So that is why it's so important to do this geomorphological study. And once you do the geomorphological study, you decide, okay, I'm going to take one sample here, 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 here. You define your sample. Usually you do string sediment and heavy mineral concentrate. With this, you can forget it, because this type of sample with the condom is much better. So what you do? You need to have like a can, like a, I don't know, a milk can, but fixed size. Okay. So you have a can. You go into the field. You take your sample the same way you would take a sample, you know, in a channel or making a hole or grabbing material from the river, and you fill the can. And then you need to know what is the volume of that can. Let's say it's 100 cubic centimeters. And then you weight that can. What is that? That's density. Grams by cubic centimeter, that is the density of the material. So that is another information that you have. If the material is mineralized, the density will be higher. So just by doing that, you're already having some information. Okay, so you have a fixed volume. Then you sieve that material, take out the big boulder. Remember that we need to work with the sandy material, and then you weight again that the heavy fraction. And that will be the percentage, because you know the whole, let's say the whole sample was 100 grams, and 20 grams were of the quartz part. So 20% of the sample was quartz, and the rest is the sand. So that remaining part, you mix it. Remember, I think I show you, you put a tarpaulin or a bag on the floor, you put the material, and you're still doing this, so it gets homogenized. When you get homogenized, you do quarter, you take material from two parts, you put it in the condom, you do the masturbation, and then you pick the heavy material, throw it away. Right now, the labs are taking the condom directly, because they already, I mean, in Canada, many people are doing this thing, so no need to take the material out, just set it. Okay, and that will be the end of this section. Let's start section number 2, but before that, let me have some water. Questions?
Questions and
The guys working on the core shaft, I saw them with helmets overall. Why are they supposed to protect themselves?
Didn't catch it. Again?
The
Talk
guy-
louder.
I said the guy is working at the core shaft. I saw in the video, one of most of them, they have helmet and I said, why did they have to do like that?
Oh, because they are working with the preparation of the sample. Where the saw is, there is a lot of dust. Even if we have the extraction, there is dust, there is the possibility of a chip, the rock hitting your eye. Outside that little section, it's okay, you can just be normal. I mean, you're just manipulating the core with your hands. Nothing else? Whew, okay, that was QA. Okay, now let's talk about QC, or quality control. It's interesting that when you start a project, almost 10%, if not more, of the volume of the samples will be controls. Because you need to control not only your work, but also the work of the labs. Once you are at an exploitation level, like producing mine, you still need to have the controls, but it will be less, like 5% or something like that. So there are many reasons why we need to have the quality control, and we will do control of our work, our samples, and the result of the lab, which is the most important one for us. So what type of samples are the most common? We have 4 types. The simplest one is the blank. And blank is a material that we know for a fact that doesn't have the mineralization that we're looking for. For example, we're working with gold, we need to have a material that we know that it doesn't have gold. And I think I repeated 3 times that we know of, because it happened to me. Working in Colombia, I was going in the field and I forgot to bring my blanks. And we're passing by a school that we're doing some repairs, and there was a pile of sand there. And I said, oh, I'm going to ask the foreman to have a little bit of this sand. They said, can I have? Yeah, sure, grab it. So I grabbed my bag of sand, went to the field, took my samples. When the result came back, all my blanks had gold.
wow.
because the sand they took it from a river downstream from a little mine. So you need to really know that your blank is blank. So how do you know that? Either you buy a blank, like a certified blank. I usually use you know, the thing that you make the house with, bricks, okay? Because bricks is usually, you know, there is very little possibility to find gold in the bricks. Or the ground, the soil, the black soil that is used for flowers, small pottery, that black soil, that one will work well for us blacks. Okay, so that's the black. The next one is duplicates, and duplicates have several different ways. You can have what is called the field duplicate, which means somebody took the sample and a few days later, a geologist or guys that are doing an audit go to the same place and take another sample from the same place. That is called field duplicate. Almost never is done because the possibility of finding exactly the place where you took a soil sample is really, really difficult. Most commonly is a duplicate from the sample itself. Okay, and the way you do it, the perfect way to do it, is you get into the field. When you get your sample, you homogenize, quarter it, and then you get half original, half duplicate, and that is great. You can do that. It's great. I mentioned the duplicate from the core. The way they are doing it is a half and then quarter. That's not very good. But the better thing is to crush everything and do the same thing. So that is duplicate. The standards. There are two types of standards. They are the one that you buy, which, by the way, is easier and cheaper for small companies, and the one that you make. The only thing that you need to know when you're buying a standard, because people say, oh, I'm going to buy 3 different standards, that one with low grade of gold, medium grade of gold, high grade of gold. No, the lab must be capable of defining, of giving you the content of gold of a high grade sample between 2 blacks. They need to do that. So you don't need to have different levels of content of gold, but what you need to know is the matrix of the standard. Usually the labs that sells this, not labs, the company that sells this standard, they have what is called the silica matrix, which will work for us. They have the carbonate matrix. Okay. So if you're working in a sedimentary basin, blah blah blah, then you go with the carbonate matrix. Or you're working in igneous rock, metamorphic rock, then you go with the silica matrix. Now, there are many places where you can buy the standards, you can go online and find it. I recommend a company called CDN Laboratories, like Canadian CDN Laboratories, because they are the cheapest one. They send you the standards directly to anywhere in the world. The ones that you're using are from that company. And they have very good selection, not only for gold, but also for multi-elements. Also for multi-elements. You know, I should have done this long time before. Yeah, that is better. Then, how you do the standard yourself. This is done when you're going to be working in a place like for 10 years, so you're a big company, you can, well, if you're a big company, you don't do this, you just buy. But if you're going to be working in a place for a long, long time, what you do is you go into the field and you collect yourself like 50 kilograms of material. And then you convince a lab, and that's the difficult part, to take off those 50 kilograms and to reduce it to 100 mesh. Okay, takes some convincing. Then you take 10 samples and you send it to laboratory 1, 10 samples to laboratory 2, 3, 4, 5. Okay. And so you get like 50 samples. You get those results and you do the average. Okay, and that you will know that your standard has a concentration of 1 gram per ton plus minus 0.5, and that is the standard that you use. It's the best type of standard, but it takes a long time to prepare. And convenient. I make a point as a geologist of be friends with the labs. The first thing I do when I start working is go to the lab, do audit, make friends, take them for coffee, etc., etc. Because at some point I'm going to ask them to do things like this. Okay? Now, what is the proportion of these samples? Blanks, you should use a blank every 30 samples. Standards, you should use a standard every 50 samples. And the duplicates, it depends. If you are working in gold, like here, I do not recommend to take duplicates every 20 samples. Why? Because even if you prepare the duplicate perfectly, there still is the nugget effect. I mean, if I get from the lab a duplicate with a different concentration of gold, I really cannot do anything. Just knowing that there may be a problem, but there is nothing I can do. I will talk about this a little bit later. Okay, so I will take every 40 samples, duplicates, when I'm in the field, where I'm working
for gold.
For gold, every 40 samples. If not, in a normal project, copper, lead, zinc, everything. And then we have finally the external control. And the external control is a sample from the pulp. After, I mean, this is done after the project is finished, okay? You take one pulp every 100 samples, and you send it to a better lab.
What do you call that, son?
External control.
External control.
External control.
Okay? So you send this sample to a better lab, but they need to use the same technology and the same method of preparation. And you receive the result. If there is a problem, for example, the external control lab gives a lower value than yours, then you just let them fight between themselves, lab B with lab C.
Wow.
And whoever wins, then they tell you. Okay? Now, let's say that the external lab wins and the values are higher. There are two ways of doing this thing. Or the lab that we use need to repeat all the samples, which they will never do. Okay? We just create a regression curve. This is why statistics is so important. And we convert all our data to the new values using a regression equation, linear regression equation, and we will work with that data. The same if it was the reverse. Our data were higher and the external results were lower, we need to adjust to the external report. And as I said, this is one sample every 100. Now, the best way of locating, putting the blanks, the duplicate, the standard is randomly. You know, like from time to time you put the blank, from time to, because that is the best way. Because random is the best way. But for sure you're gonna make mistakes. I mean, that is guaranteed. We are humans. And not only humans, we are geologists. So we're gonna make mistakes. Okay? So what I propose everywhere I work is to create a list from number 0 or number 1 to number 99. And let's say, in this case, blanks will be the sample 33, 66, and 99. This is 30 samples. The duplicate will be sample 40 and 80. The standard will be sample 25 and 75. That's 50 numbers. And the external control will be the number 1. Okay. So that way, when you receive the data, just by looking at the lab report, you will immediately see if there is a problem, because you know sample 33, 66, and 99 must be 0. And if it carries gold, you already know, just by looking, that there is a problem. You know that your standard is 1.26, and sample 25 gave 3 grams per ton. You know, without doing any analysis, you know that there is a error. This method is also good because you can teach the people that will be working, preparing the sample, because the geologist doesn't prepare the sample, it's a technical task, to have this list there. So they will know also that, okay, here must be a blank, here must be a duplicate, here must be a standard. Okay, so we work together. Of course, the lab doesn't know, cannot know about this list. And you can, every 2-3 years, you want to change the numbers. So let's say, okay, sample now will be 20, 50, and 80 will be the blanks, and whatever, you can change. To tell you the truth, labs don't have the time to figure out these things. So you can use this list forever. Now, there are 2 points now that are very important, and one that we need to make a decision right now. We need to have a geologist, a person here that will be the only person that will receive the result from the lab before anybody else, and that person will do the control of the quality of the samples. Only after that person certifies that this data is okay, then it will go into the database, it will go into management, it will go into the field. Because I cannot tell you how many times, well, I have 37 years of experience, but it happened to me a lot, that the lab making a mistake, or we made a mistake and put the standard in another place, and when the result comes, wow, 10 grams per ton. Immediately the president of the company is calling all the shareholders, we just intercepted 10 grams per ton, and everybody buying shares. And then 2 days later, oh no, sorry.
It's the standard.
It was a standard. So, where I work, I always say there must be one person, we are not going to decide these things, but you need to have one person, a geologist, okay, that will be the only person, because the results are going to be sent by email, that will receive this email, and his job, apart from anything else, the day he receives this result, is to check the quality control, approve it, and once it's approved, go into the system and goes. Okay? This is really important. Okay, now, how do we know that a blank failed, a duplicate failed, whatever? This is the job of this person. First of all, I have a friend, his name is Simon. I forgot his name. We always call each other, in Cuba we call each other by his family name all the time. Armando Simon. For me, he is the top dog on quality assurance and quality control in the world. And when he gives his conference, he always tells one thing that I like to say. When you see an error, especially a big error, check yourself first. Before calling the lab and say, oh, you screw up, blah, 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 check yourself first. Check that the sample was really a blank. Check that you didn't sneeze in the duplicate when you send it and you are throwing away gold through your nose. Whatever, check yourself first. But then, let's say blanks. We would say that the blank has failed if the content, the value, is 10 times higher than the limit of detection of the element at the lab. Write this down. So, for example, if the detection limit of the lab for gold is 0.5 gram per ton, or 0.05, let's say, 0.05 gram per ton, if we get a value that is equal or higher than 0.5, that blank fails, because it's 10 times higher than the limit. 0.5, 0.6, 0.7, anything above 0.5, that blank fails. Now, when a blank fails, we notify the lab, and the lab must repeat 5 samples from the original material, from the sample that failed, 5 more, the sample that failed plus 4 more samples. They need to prepare the whole thing and do the whole analysis. And at the cost of the lab. We don't pay for that. And when you do your agreement with the bank, with the lab, you need to specify all these things. Who is paying for, what is the limit, etc., etc. So that is the blank. Now, duplicates. We check the duplicates not sample against sample. We do a statistical analysis, which is called the student test and the Fisher test. And for the person that will be doing this thing, I will later talk with him and give him the formula, but basically you organize in a column all your samples, all your duplicates, and for each column you determine the average value and the standard deviation. And both student and Fisher use those 2 values, and they determine how close the original value are to the duplicates. And if they are close enough, then you say that the duplicate is okay. Now, let's say that the duplicate failed. If we are working with a copper, lead thing, whatever, we call the lab, tell them this duplicate fails, they will repeat that sample, just a sample. And whatever value comes from the lab, we will do an average, and that is the value that we're going to use. If it is gold that we're working with, as I mentioned, we cannot expect anything better than whatever they're giving us because of the gold nugget effect. So what happens? Let's say that we have duplicate failing. Well, we will tell the lab, just inform them, say, we are having some problem with this sample duplicate, but that's okay, just for you to know. What you could do, if for example, if this is soil sampling, take more sample. If you were having 100 grams, take 200 grams, or even 300 grams, because the more volume you have, the less chance for the nugget effect. If you are in the core, we are pretty limited there, okay? Because we cannot take samples of 2 meters. Why? First of all, because we have the limitation of lithology. We need to take samples within lithology, but also we don't want to have too heavy of sample because the lab will charge you for the extra weight. They will process 2 to 3 kilograms, no problem, but you're sending them a 5-6 kilogram sample, they almost double the price of the preparation. So basically, we're screwed. There is not much that we can do, except in soil sampling, we can take more sample. Now, here's the interesting part. When the standard fails, and I'm gonna use the black horse. I hope this is, yeah, okay. So let's say these are the samples. And we have our sample, our standard here. Okay? If the standard fails, and it's not an error of ours, the lab must repeat 25 samples before and 25 samples after, because we are putting a standard every 50 samples. So this standard here didn't fail, so that's why we have 25 and 25. Again, at the cost of the lab. But the lab itself uses their own standard. And let's say that they had a standard here and a standard here. In that case, they can only repeat the sample from here through here. Okay? So it will be less. The important thing to understand is that we are going to repeat only the samples between the standards that did not fail. Okay? So if they didn't have any internal control, they need to repeat the 50 samples. But if they have some control within this, it will be from the standard that didn't fail to the standard that didn't fail. It doesn't matter if it is ours or theirs. Again, this is why it's so important first to have all these things discussed with the lab beforehand and to be in good terms with the lab. With the standard control, it's like with the duplicate. You find the student criteria, the feature criteria, you determine if the values are similar enough. If they are similar enough, no problem. If they are different, and you let the two labs fight between them and the lab that won, then you do a regression analysis and to convert your data to the data of the lab. Usually, you will use SGS as the reference lab because they have the fame of being the best, well-deserved fame. But I will use them only as an arbitrage, you know. Normally I will use ALS or other. There is a company called Bureau Veritas.
Bureau Veritas, yeah.
Do not use them. Unless you do some audit. I mean, they are presenting themselves like the Pope. Not very okay.
I love Alex Stewart.
Alex Stewart is good, but this is for gold, for determining the carats of the gold. I mean, this is not for normal multi-element analysis. This is for industrial, determining carat, how many carats the gold has, etc. Yes, they are very good for that. Now, this is also part of the QA. You need to give the lab how you want the sample to be prepared. Because if not, they will prepare it the same way they do. They take the sample, they weigh it, they put it in an oven, they dry it, they crush it, they pulverize, they split it, they give you 250 grams, and the rest is reagents that you need to take. Okay? And normally that will work, but there are specificity. For example, if you are working in exploration, you would like to have the value of mercury. Okay, so the drying in the oven cannot be higher than 90 degrees. Because if not, you're going to lose the mercury, it just sublimates. If you don't care, then gas on, put 300 and dry it up. But these are the things that you need to tell the lab. Okay, you need to, especially if it is a new lab, you will put duplicates for the crushing and for the pulverizing. Okay, so if there is a problem, they can figure out where is the problem, at the stage of crushing or at the stage of pulverizing. The labs usually have lines for normal samples and mineralized samples to avoid contamination. So these are the things that you need to check. I mean, I have documents of how to do an audit of the lab, and at some point I will share that to you. And what else is here? That's it, I think. Important. So now we are approaching the best part, which is naming rocks in the field. But let's have a little break. Huh? Yes, let me